So, good morning, students. Next topic is Heisenberg uncertainty principle. So, according to this principle, okay, is explained about uncertainty of a system. The definition of the uncertainty principle. So, is it is impossible to specify precisely, simultaneously the value of both members of particular pair of physical variables that describe the behavior of an atomic system. That means, so suppose this is the atomic system. So in that, okay, this Heisenberg and uncertainty principle is if we are applied to the atomic system. Okay, in that atomic system, suppose let us we have to find out a atom is travel from one place to another place. Let us consider. So if we travel, the distance is x and it has a momentum is p. So then, okay, it has a, now it has two variables. Suppose we want to find out the atom, this atom's particular position and also momentum. It is impossible to at a time to find out these two variables. Okay, so that means not only the atomic system, okay, uncertainty principle is, it is tells that it is whatever impossible, okay, it is impossible to find out the two variables, find out to measure two variables at a time with accuracy. That is called as uncertainty principle. Okay, let us, okay, suppose these how much of uncertainty is taken here, according to Heisenberg, okay, the magnitude of uncertainties of two variables must be at least Planck constant. That means, for example, two variables. Let us the pair of two variables, physical variables a and b. Suppose, okay, it is whatever it may be, position or momentum or also energy or time, whatever it may be. So the pair of suppose a is a physical quantity and b is a physical quantity or physical variable. Then, so the uncertainty in measuring of two variables, that is delta A into delta B is always equal to or approximately equal to Planck's constant. That means delta A is indicates here uncertainty of the variable A. Okay, that means uncertainty means, okay, that is error. Okay, that is not exact value of the A. Okay, how much of, suppose a has suppose exact value of a is, suppose it is a position, okay, 1.5 meters. It is an example. Okay, delta x is, so delta a is nothing but, so a in 1.49. That means here meters. Okay, uncertainty means actually accuracy value. Okay, accuracy value is 1.5 meters, but so it is shows the if it is shows the value is 1.49. There is a delta A is nothing but, so uncertainty means, okay, the difference between actual value and present, that is showing value. So that is called as uncertainty. Uncertainty means, so that is changing value. Okay, that is showing the sum of the error value. So okay, that is called as, so delta x is a that is uncertainty of variable A and uncertainty of variable B. That is changing value in A and that is not exact value. Okay, how much of difference is there, that is indicate that delta x, that means error value. Okay, delta x, delta A into delta B is equal to H according to Einstein, according to Heisenberg. So the product of these two variables, when it is measuring the uncertainties takes place is H. Okay, H is approximately equal to Planck's constant. Okay, that is 1.625 into 10 to the power of minus 24. Okay, so this uncertainty is taken place. Okay, now let us come to detail in the uncertainty principle. So if the two variable, here I am taking the two examples, that is, okay, two physical quantities a and b. In place of a and b, so for the pair of two variables, here position and momentum is one of the pair. Okay, so if position and momentum uncertainty in that, so it is impossible to measure both the position and momentum of the particle simultaneously with the desired accuracy. That means, suppose a car is travel with some of the distance. This is a car. Okay, if it is travel some of the distance, okay, then after traveling the distance, okay, it has the change. It has some, it changing its position, and also it has possesses the momentum. Okay, so now we want to calculate its position and momentum. So we cannot find exact position and momentum at a time. Okay, that is it is impossible. That principle is called as Heisenberg uncertainty. Okay, suppose when we are measuring the x and that is position and momentum. Okay, if delta x is the uncertainty in measurement of position, okay, that means some of the change in position and change value in the position, and delta p is the uncertainty of the momentum. That means it is also some of the change in momentum when we are measuring both them. So our uncertainty principle is tells that uncertainty in x position and uncertainty in momentum, its product is always equal to h. H, and also it can also defined as another way, that is the product of uncertainty position and uncertainty momentum is greater than h by 4 pi. Okay, so that it is also tells that uncertainty principle. Okay, very clear. Next, similarly, another pair, okay, one pair is position and momentum, okay, and similarly, energy and time uncertainty. So, what is energy and uncertainty principle? So, similarly, we cannot, okay, how to define it here also? So, we cannot measure, it is impossible to measure energy and momentum simultaneously with accuracy. Okay, that is called as energy, time, uncertainty. Okay, now, okay, what is, okay, we have to show that. So similarly, delta e and delta t is delta e and delta t is greater than or equal to h by 4 pi. Now we have to show that. Okay, we will show that the uncertainty of x and delta t is greater than or equal to h by 4 pi. Now let us consider in case of a free particle. Now let us consider a free particle with its mass is m0, moving along the x direction with a velocity px. Then the kinetic energy of the particle is, we know that, okay, if it is a particle, free particle, it is moving some of the distance with some velocity v x direction, that is vx, and its mass is, rest mass is m0. Now from the kinetic energy equation is, we know that the relation between the kinetic energy and momentum, E is equal to p square by 2m. Here p is the momentum of the particle and m is the mass of the particle. Now, okay, if delta x is the uncertainty in the measure of in the measurement of energy, and delta px is the uncertainty in the measurement of momentum. Let us, so previously we discussed about uncertainty in position and uncertainty in momentum. Similarly, here also uncertainty in energy is delta E, and uncertainty in momentum is delta px. Okay, now, so, okay, with the above equation, from equation number 1, we had to differentiating both sides. So that is E is becomes delta E is equal to, next p square is, okay, p square is px square. Okay, it can be when we are differentiating, that is 2px. Okay, when px is again it is differentiated, that is delta px by, okay, m is mass is constant, so that's why it is same, that is 2m0. Okay, now this delta px and p is put here, and remaining terms are taken to left side, that is delta e into delta 2 get cancelled, remaining is delta E into m0. Delta E into m0 is one side and delta Px into P. Okay, delta Px is equal to now. So this Px is taken to right side, then it will become as a denominator. Next, delta Px is equal to next m0 into this into delta E. Okay, and P is the momentum. So again, this momentum is can be written as the product of mass and velocity. So that's why. So in place of Px we can replace with m0 and Vx. Vx. So that is equal to delta E by delta Vx. So this is equation number 1. Okay. So now suppose from if delta t is the uncertainty in measure of time. We are consider delta t is uncertainty in measurement of time in free particle. Then so we know that what is the expression? Dx is the position. Okay, we know that position is equal to distance is equal to velocity into time. Similarly, the uncertainty in position is equal to dx into velocity into suppose in these two variables, if it is uncertainty is taken as a time. Okay, we represent with delta t. Okay, so then it is cancelled by 3. Then equation number 2 we get from previously from equation number 2 delta delta px is equal to delta E by delta Vx. Okay, delta px is equal to delta E by Vx. Okay, so we have to from equation number 3. It is equation number 3. Equation number 3 we are multiply with delta px. We get okay. As usual, that is Vx into delta t is same. Remaining we are multiply with delta px. But delta px value is delta E into Vx. Okay, from equation number 2. So that is delta E by Vx. So Vx gets cancelled. So remaining is delta E into delta T. Okay, from this equation, okay, we conclude that delta x into delta P, that is the product of uncertainty in x and the product of uncertainty in T is always equal to delta E into delta P. Okay, so from this, okay, but delta x into delta P, we know that greater than or equal to h by 4 pi from the uncertainty principle of Heisenberg uncertainty principle. Similarly, so from this conclusion, delta x into delta T is equal to delta E into delta T. So then it is also delta E into delta T is also equal greater than or equal to h by 4. So this is the uncertainty principle. Okay, with the variables of energy and time. Okay, so this is our topic. Okay, thank you.